When talking about electricity, we need to look at the two different types of electricity. The first type is static electricity. Static electricity is a temporary buildup of electrons. Now, the word temporary means that it doesn't last forever, and a buildup means that it doesn't travel anywhere. Once it is present, it stays on that object. Now, if it's going to stay, how is it only temporary? Over time, that electricity will dissipate, and you'll have a discharge of that electricity. The electrons will be what moves. So we move electrons to create charge. And the way electrons move is through a concept called electron affinity. Electron affinity is the love of electrons. Each object has their own different value for electron affinity. So this balloon has a higher electron affinity than this person's hair. So when I rub the balloon on the hair, the electrons will transfer from the hair to the balloon, giving the balloon a temporary negative charge and the hair a temporary positive charge. The electrons are the only thing that moves. There are three ways to transfer static electricity. We have friction, conduction, and induction. Friction is when the electricity is transferred because of rubbing two objects in opposite directions. If you've ever walked across carpet in socks and then touched a light socket, you know that you can get static electricity built up from walking across the carpet. If you've ever forgotten to put towel sheets in the dryer when you were washing clothes of different textures, like a silk slip with a bath towel, you know that that slip is going to get static cling on it through the dryer because of the friction of rubbing inside the dryer. Now, we also have a weather system, the storm front. When clouds come against each other in our atmosphere, they rub against each other. So as one cloud goes over the other, there's friction between those two clouds, and we will actually see cloud-to-cloud lightning. Conduction is when we have direct contact from one object to the other. So when I touch the light switch and I get that discharge. So if I shock someone else or if I feel the zap myself, that's through conduction. Lightning rods are put on our houses as a way to keep the electricity from going through any other part of our home. The lightning rod conducts the electricity from the point of the strike straight to the ground. Induction is when we take a charged object and make electrons in a neutral object rearrange. We're going to do a lab that uses a balloon that has charge, and we're going to bring it close to several different objects to see what that charged object will do to the salt, the pepper, the aluminum foil, and the tissue. All four of those are neutral substances, but when they're in the presence of another object that is charged, they will do some interesting things. Now, we're not going to touch the object to them because touching would be conduction. We want to induce charge into the neutral substance. An example of this is when the storm front comes over the area that you're in, you might start to feel your skin get prickly or the hairs on your neck stand up. And what you're feeling is the induced charge on the earth as the storm comes over you. An electroscope is a device that we use to detect charge. Now, an electroscope does not tell us positive or negative. It just simply tells us either it's charged or it's not charged. Charge will all be the same charge, so I can't have positive and negative on the electroscope at the same time. It's either going to be positive or negative, never both. Now, if I look at an electroscope and I see that the leaves are touching, that does not mean that the charge is attracting. It means that there's no charge. When the leaves are repelled, when this leaf that's allowed to move is pushing away from the one that's stationary, I know that there's a charge present on the electroscope. I don't know whether it's positive or negative, but I do know that there's a charge.